Hello, I'm Maruk Said, your microbiology guide. Let's explore in-depth micro techniques and uncover groundbreaking insight together on this educational journey into the fascinating realms of microbes.
Homemade versus commercial ghee. A scientific comparison of fermentation, nutrition, and health benefits. Table of content. Introduction. Quality certification and global standards. Types of ghee based on production method. Role of fermentation. Fat-soluble vitamins. Vitamin K conversion. Beta-Carotene to retinol conversion. Omega-3, fatty acids in ghee. Influence of animal diet. Physiological. Benefits of DHA and EPA. Omega-3 to omega-6 ratio. Cost difference. Explained. Conclusion. Introduction. Ghee is a clarified form of milk fat obtained by removing water and milk solids, making it a stable cooking fat used worldwide. It is valued not only for culinary purposes, but also as a functional food due to its content of fat-soluble vitamins and bioactive lipids. Although different types of ghee may look similar in color, texture, and aroma, their nutritional quality and physiological effects can differ greatly. These differences arise primarily from the method of processing and preparation rather than the raw material alone. On the basis of production method, ghee can be broadly classified into two main types: commercial or dairy-produced ghee, manufactured using industrial processes for large-scale production. Homemade ghee, prepared through traditional methods that often involve fermentation and slow heat treatment. The most important distinction between these two types lies in the presence or absence of fermentation, which influences the biochemical transformation of nutrients, the formation of bioactive compounds, the overall bioavailability and functional health benefits of the final product. As a result, ghee should not be evaluated solely on appearance or fat content, but on its processing pathway and nutritional functionality. If you have watched till here, don't forget to subscribe to Family of Science Lovers. Press the bell icon button so you are always updated. Quality certification and global standards. Commercially produced GHE is regulated under international and national food quality and safety systems to ensure consistency, purity, and consumer safety. These regulatory frameworks define acceptable limits for fat composition, moisture content, contaminants, and processing hygiene. Commonly recognized global reference standards include Codex Alimentarius, FAO/WHO standards, which provide internationally accepted guidelines for milk fat and clarified butter products used in global trade. ISO 22000 Food Safety Management System, which focuses on hazard analysis, quality control, and safe handling throughout the food production chain. National Dairy Quality Certification marks, which vary by country, but generally ensure compliance with local food laws and quality benchmarks. Oleic acid-based quality classification, commercial ghee. In industrial production, commercial ghee may be classified according to its oleic acid content, which is considered an indicator of fat quality and stability. Oleic acid levels help standardize products and allow grading across large-scale batches. Based on oleic acid percentage, commercial ghee can be categorized as less than or equal to 1% oleic acid, classified as special or premium grade, indicating higher fat quality. 1.3 to 1.5% oleic acid, classified as standard grade, meeting routine commercial quality requirements. Less than or equal to 2% oleic acid, classified as general grade, acceptable for general consumption but with lower premium value. These grading systems are applicable only to industrially manufactured DHA, where uniform processing and large batch sizes allow standard chemical analysis. Homemade or traditionally prepared ghee does not fall under such industrial classifications because it is produced in small batches and shows natural variability in composition. Types of ghee based on production method. 1. Commercial, dairy-produced. Ghee, manufactured using industrial dairy processing techniques. Milk is heated and cooled to separate cream. Cream is isolated using centrifugation. Cream is rapidly heated to extract milk fat. The process is efficient but excludes natural fermentation. 2. Homemade ghee, traditional fermented method. Prepared through a biological multi-step process. Milk is fermented into curd. Curd is churned to obtain butter and buttermilk. Butter is slowly heated to form ghee. This method allows microbial-driven nutrient modification. Role of fermentation. Fermentation is the most critical factor that differentiates homemade ghee from commercially produced ghee. In traditional preparation methods, milk or cream is first fermented into curd, creating a biologically active intermediate stage before ghee formation. This fermentation process involves beneficial microorganisms, primarily lactic acid bacteria, such as Lactobacillus species. These microbes initiate biochemical transformations in milk components that do not occur in non-fermented systems. As a result of fermentation, several nutritional advantages are observed. Improved digestibility due to partial breakdown of complex milk components and reduction of lactose and protein residues. Enhanced vitamin conversion, particularly the transformation of certain fat-soluble vitamins into more biologically active forms. Greater nutrient bioavailability, allowing fats, vitamins, and bioactive compounds to be more efficiently absorbed by the human body. In contrast, commercial ghee production bypasses the fermentation step, relying on direct cream separation and heat treatment. The absence of fermentation limits microbial-driven nutrient modification, resulting in a product that is chemically standardized but functionally less complex. Fat-soluble vitamins. Vitamins present in both types. Ghee, regardless of its method of preparation, is a rich source of fat-soluble vitamins, which are efficiently absorbed due to the high lipid content of the matrix. Both commercial and homemade ghee contain the following essential fat-soluble vitamins. Vitamin A, which supports vision, immune function, and epithelial health. Vitamin D, which plays a crucial role in calcium absorption, bone mineralization, and immune regulation. Vitamin E, a potent antioxidant that protects cell membranes from oxidative damage. Vitamin K, which is essential for normal blood clotting and calcium metabolism. Although the measured quantities of these vitamins may appear similar in laboratory analysis, their biological activity and effectiveness in the body can differ significantly. These differences are influenced by the form in which the vitamin is present, the extent of microbial and enzymatic modification during processing, the overall bioavailability within the fat matrix. Consequently, the nutritional impact of fat-soluble vitamins in GE depends not only on their presence, but also on how they are transformed and utilized by the body. Vitamin K conversion. Vitamin K in ghee exists in different forms, and its nutritional significance depends on biochemical conversion during processing. The two major forms of vitamin K relevant to ghee are vitamin K1, phylloquinone, and vitamin K2, menaquinone. Vitamin K1, phylloquinone. Vitamin K1 is naturally present in milk fat and is found in both commercial and homemade ghee. Its primary physiological role is to support normal blood coagulation by activating clotting factors. While essential, vitamin K1 has limited activity in calcium redistribution within the body. Vitamin K2, menaquinone. Vitamin K2 is formed during fermentation, driven by microbial enzymatic activity. It is heat-stable, allowing it to remain active even after the heating steps involved in GHE preparation. Vitamin K2 is highly absorbable and plays a critical role in long-term metabolic health. It is essential for cardiovascular integrity and bone mineralization. Effect of processing method. Homemade, traditionally fermented DHE supports the conversion of vitamin K1 to vitamin K2 through microbial action. Commercial ghee, which bypasses fermentation, shows limited or negligible K1 to K2 conversion. Health impact of vitamin K2. Vitamin K2 helps remove excess calcium from blood vessels, preventing abnormal mineral deposition. It plays a key role in preventing arterial calcification, which is associated with cardiovascular disease. Adequate vitamin K2 intake is linked to a reduced risk of cardiovascular disorders and improved vascular health. Download our microbiology study app made for researchers like you. Beta-Carotene to retinol conversion. Milk fat naturally contains beta-carotene, a carotenoid pigment that also acts as a precursor of vitamin A. Beta-carotene itself must undergo biochemical conversion in order to be utilized efficiently by the human body. During traditional fermentation, microbial and enzymatic activity promotes the conversion of beta-carotene into retinol, or retinol precursors. Retinol represents the biologically active form of vitamin A, which is directly involved in vision, immune function, and cellular growth. Compared to beta-carotene, retinol is more readily absorbed and metabolized, leading to improved vitamin A bioavailability. This nutrient transformation is prominent in homemade ghee, where fermentation precedes heat processing. In contrast, commercial ghee production, which lacks fermentation, shows minimal conversion of beta-carotene into active retinol. Omega-3 fatty acids in ghee. Key omega-3 components. Ghee contains omega-3 fatty acids, which are essential polyunsaturated fats required for normal physiological function. Among the most important omega-3 components present in high-quality ghee are DHA, docosahexaenoic acid, a major structural component of brain and retinal tissues; EPA, eicosapentaenoic acid, which plays a key role in anti-inflammatory and cardiovascular processes. DHA and EPA are widely marketed in the form of dietary supplements, particularly for heart and brain health. However, these fatty acids can occur naturally in GHE, especially when it is produced using traditional methods and derived from milk of animals with diverse nutrient-rich diets. When present in GEG, DHA and EPA are delivered in a natural lipid matrix, which may enhance their stability and absorption compared to isolated supplement forms. Influence of animal diet. The fatty acid profile of ghee is strongly influenced by the animal's diet, making feed quality a critical determinant of nutritional value. Animals that graze on diverse green forage naturally consume higher levels of alpha-linolenic acid, ALA, a plant-derived omega-3 fatty acid. Within the rumen, microbial populations metabolize ALA and convert it into longer-chain omega-3 fatty acids, particularly DHA and EPA. These converted omega-3 fatty acids are subsequently incorporated into the milk fat and therefore become part of the ghee produced from that milk. In contrast, restricted or grain-heavy feeding systems limit ALA intake and alter rumen microbial activity. Such feeding practices result in reduced omega-3 content and quality in milk fat and the final ghee product. Physiological benefits of DHA and EPA. Digestive health. Reduce intestinal inflammation, lower risk of irritable bowel conditions, provide protection against colon disorders. Brain and nervous system. Support neurotransmitter activity, improve memory and cognition, reduce risk of dementia and neurodegenerative disorders. DHA supports brain-derived neurotrophic factor, BDNF. Maternal and fetal health. DHA and EPA play a critical role during pregnancy, as they are essential for optimal maternal and fetal health. Adequate intake of DHA supports fetal brain and nervous system development, particularly during the later stages of gestation, when neural growth is rapid. EPA contributes to healthy cardiovascular development of the fetus by supporting blood vessel formation and regulating inflammatory responses. These omega-3 fatty acids also help maintain maternal cardiovascular and metabolic health during pregnancy. The presence of naturally occurring DHA and EPA in quality GHE highlights why traditional dietary inclusion of ghee has long been emphasized in maternal nutrition. Modern nutritional science increasingly supports this practice, demonstrating that such traditional foods can align well with evidence-based maternal dietary recommendations. Joint health and resolvins. DHA and EPA act as biochemical precursors of resolvins, a class of specialized lipid mediators involved in resolving inflammation. Resolvins are not general anti-inflammatory agents. Instead, they actively regulate and terminate inflammatory responses once tissue repair has begun. By controlling excessive inflammation, resolvins help protect synovial joints from chronic inflammatory damage. They support the maintenance and regeneration of synovial fluid, which is essential for joint lubrication and smooth movement. Adequate resolvin activity contributes to reduced joint stiffness and discomfort, particularly in weight-bearing and frequently used joints. Over time, these mechanisms help enhance long-term joint mobility and functional movement, supporting musculoskeletal health. Omega-3 to omega-6 ratio. The ratio of omega-3 to omega-6 fatty acids is an important determinant of the inflammatory potential of dietary fats. Homemade, traditionally prepared ghee tends to maintain a more favorable omega-3 to omega-6 balance due to fermentation and better quality milk fat. In contrast, commercial ghee often shows an imbalanced ratio, typically with relatively higher omega-6 levels. Excess omega-6 fatty acids can promote pro-inflammatory pathways when not balanced by sufficient omega-3 intake. A proper omega-3 to omega-6 ratio helps regulate inflammatory responses, reducing the risk of chronic inflammation. Maintaining this balance also supports cardiovascular health, contributing to healthier blood vessels and improved heart function. Cost difference explained. The cost of ghee varies according to the method of production, processing time, and nutritional value. Commercial ghee is generally moderately priced due to large-scale manufacturing, standardized processes, and higher production efficiency. Homemade or traditionally prepared ghee is typically more expensive, reflecting the labor-intensive and time-consuming nature of its preparation. The higher cost of homemade ghee is justified by several factors. Extended fermentation time, which allows microbial and enzymatic processes to enhance nutritional quality. Lower yield, as traditional methods prioritize quality over quantity and involve multiple processing steps. Greater nutrient transformation, including improved vitamin bioavailability and formation of bioactive compounds. Therefore, the price difference is not merely economic, but reflects differences in processing complexity and functional nutritional value. Conclusion. Both commercial and homemade ghee are composed predominantly of fat, accounting for more than 99% of their total content. Each type provides essential fatty acids, along with important fat-soluble vitamins such as vitamins A, D, E, and K. Despite these similarities, homemade ghee offers superior functional nutrition, primarily due to fermentation-driven biochemical transformations. Fermentation enhances the formation of biologically active vitamin K2, which plays a critical role in cardiovascular and bone health. Homemade ghee also maintains a more optimal omega-3 to omega-6 fatty acid balance, supporting anti-inflammatory pathways. The presence of DHA and EPA, derived resolvins, further contributes to joint protection and inflammation regulation. Improved nutrient bioavailability, resulting from traditional processing, distinguishes homemade ghee from commercially produced ghee, making it functionally more beneficial despite similar fat content. Thank you so much for watching. Don't forget to subscribe to my channel, press the bell icon button. Thank you!